thought it was recording. Okay. Well, it's recording now. So, those of you who are watching this, and there are several of you because you decided not to show up, I'm missing your grades from problem set 7 to today. So, you can bring them by, or again, scan pics and email them to me. I just want to make sure that I enter the correct letter grade for you in SOAR. 70% of your grade, well, actually more like closer to 85% of your grade. Well, if I can get test 2 at least, that would give me the data for 85% of your grade. I don't think there's a situation where someone has a drastically different homework average from the first half of the semester compared to the second half. It's probably pretty comparable. But I know many people's, if everything that's happened hasn't been enough, I managed to perform the extraordinary feat of cutting my finger while opening a box of chalk just a few minutes ago. The bleeding seems to have stopped, so no, it's not. It's going to be fun. Hopefully, as long as it doesn't carry over to my students, because right after this class, one of my master students has a prospectus presentation, and then another one at noon. And actually, that student is bringing me might bring me a Thunderbolt cable so I can hopefully resolve this. So if I'm able, or iTech is able to recover your grades, I'll send an email, so then you won't have to bring anything after that. Also, there's time, because we have the rest of this week, all of next week, so you don't have to hurry back and get your stuff. But it's, in fact, if anything, you might want to wait a little bit in case I'm able to. Yeah. So. Okay. I'm trying not to use the hundreds for everybody approach, but also the main thing is I would hate to underestimate anyone's grade. And Dr. Schroeder is aware of the situation, so I can get suggestions from him. Because he's witnessed these kind of things happen before. But I guess all we do is take whatever data we can to try to determine the correct grade. Okay, now hopefully this will keep recording because I've had enough gone wrong today and it's early yet. So today is review day, and I told you bring your questions about the the practice final or just about the final in general. So fire away. What do you got? Number 4. A variation of parameters 1. Okay. Is there any particular part of a problem that caused trouble? Or?
Yes, whenever you did W1T or 2T.
Yeah. So as far as like setting up the integral, what?
I can do that.
I'm sorry. So doing the integral is fine, but but getting the thing to integrate, yeah. Okay. All right. So we have characteristic polynomial. So your roots are equal to 0 plus or minus 1. So we have our 3 linearly our fundamental set of solutions: 1 e to the t and e to the minus t. Okay. So what happens is so first you need Wronskian. So you write your solutions in no particular order, as long as you're consistent in how you order them throughout this. So solutions across the top, so y goes here, y prime here, y double prime, and you just keep going. For instance, if it's been a 4-4 equation, you'd have a 4x4 matrix, 4 solutions, and you go down to y triple prime. So then the derivatives go here. Now, as far as for 3 by 3, there's a specific trick, but that only applies to 3 by 3. So I'm going to do this in a more general way, so that you can adapt it to a 4-folder case. So what you can do is either go across, the top row or the first column. That's your choice. In this case, going down the first column would be advantageous because of these zeros. So that's the approach I'm going to take in this case. You alternate signs starting from plus. And what happens is, say if you go down the first column, it would take, you multiply this element by the determinant of the smaller matrix you get by deleting the first row and first column. So what you would get in this case is 1 times the determinant of the 2 by 2 matrix obtained after deleting that first row and first column. Whatever row and column this entry is actually in. And then I would go down to the next entry and multiply this by the 2 by 2 matrix obtained by deleting this row and this column. So it would be these entries and these entries, but it's 0, so I don't need to in this case. So we end up with e to the t times e to the minus t, which is 1, minus minus 1. So we get 2 for Wronskian in that case. It's always, when you have distinct exponentials here, it turns out to be 2 times e to the sum of these. So in this case, 2 times e to the 0. Now that's the denominator for your integrals. For the numerators, so for W1, so you have your Wronskian down below, which is 2, and then the determinant up here is, since it's W1, you replace the first column by a column that is all zeros except for your G of t goes to the bottom position. And then the other 2 columns come from your Wronskian. So the determinant in this case, if you use the same approach, where you go down the first column, so this times this determinant, minus this times the entry, determinant of the entries you have in circles, plus this entry times the determinant of this matrix up here. So what you would get is t times the determinant of you would get that. Okay. Wait a minute. Oh my God! What did? Okay, hold on a second. Oh wow! I really blew it in this practice problem. No wonder I get a question about it. It's supposed to be t because that's the right-hand side. In the solution, I have 1. Sorry about that. Okay. Yes, that would cause substantial confusion. Okay. What?
I've been doing it wrong.
Oh, beyond that, or?
Oh no, just that.
Okay. Well, no, really, I was doing it wrong. Okay. So, no, yeah, the G of t is what goes here. I'm not sure what possessed me to put 1. Okay. I will update the solution to reflect that. Okay. Oh, this is interesting. Oh, I see what I did. Okay. Actually, the solution is correct because it's just written differently. Because what always happens when you this determinant, because the rest of the column is all zeros, the determinant is it's always going to work out to be your g of t times some determinant, in this case a 2 by 2 or one size less. So therefore you can always factor out g of t. So this is the same as putting a t out here and then putting a 1 here. Because notice, if you look a little further down, the way I write this for w1 of t is this determinant. Okay, so I'll just write out the determinant. And I wrote the g of t is actually written off to the side. See that in the solution? And then the Wronskian down here, which is 2. So the final solution you get is the correct one. So it's your choice. You can either put the g of t in here, or you can put a 1 and write the g of t off to the side. It's the same thing, because the fact that the rest of the column is zeros allows you to factor it out. So if I move on to the second one, okay. Are we good now with that part? Okay. Was there any other part, this is for anybody, but that presented difficulty? Okay. So it's, okay. So, what I would suggest, because there are many different ways to compute the determinant. So for a now, one thing you can do, because one thing that can be kind of nice is to have a situation like this, where you have zeros all the way down this first column. And so whatever you have up here, you can just multiply that by the determinant of this lower right one right here. Now, what you can always do, so because for your numerators, you're always going to have something like that. You're always going to have a column that's mostly zeros. So when computing determinants, swapping any two rows or columns changes the sign. So if you want to rearrange the matrix basically by swapping rows and columns to bring about a situation like maybe like this, that's easier to handle, then you can do that. You just have to remember to swap signs each time you swap two rows or columns. Hold on, my thermostat backing up again. So one thing I can tell you for a situation like when you're computing these numerators, since one of the columns is always going to be mostly zeros, like if you're computing W3, your third column will be mostly zeros, and then you can put it so there's a 1 or a G of T at the bottom. You can rearrange by swapping rows and columns to have a situation where the determinant of, you have something up here like just 1, and then you have zeros down below, and it doesn't matter what's in here, and I'll just call this matrix B. So the determinant of this just turns out to be the determinant of whatever's down here. That's a good way to make the problem smaller. Okay. Any other questions about this problem or any other problem?
Number 7.
7. Okay. So this kind of problem we're dealing with on Monday. We have all right. Now, so again, is there a particular part that caused more trouble?
The first, like the transform, I just couldn't figure out how it
Okay.
came about.
So second derivative goes to s squared transform of y minus y prime of 0 minus s y of 0. So in this case, with your initial conditions, we have y prime of 0 is 1. And then here that's all we have because y of 0 is 0. Okay. Now, and we don't have y prime, so we don't need to bother with that. So that's why your transform equation turns out to be s squared y hat of s minus 1 plus y hat of s on the left side. And then on the right side, you have the transform of the step function. So this value, 3 pi, is your c. So you get e to the minus cs, so minus 3 pi s. And since this is multiplying just 1, you multiply the transform of 1, which is 1 over s. All right. And then anything not involving y hat gets moved to the other side. And that's why y hat of s turns out to be e to minus 3 pi s, 1 over s plus 1, all over s squared plus 1. So what I would suggest in that case, okay. All right. Is if you well, you have a choice at this point. Like what I did in the solution was I left it as 2 separate things. So we have e to the minus 3 pi s 1 over s squared plus 1. And then what's left is 1 over s squared plus 1. Now in the previous example, I just put everything into one fraction. I didn't bother doing that in this case because this is something that we know how to handle. This does inverse transforms to sine t. And then you need to figure out how to invert that and then take the exponential into account at the end. So for this, you would need partial fractions. So that would be equal to a over s plus bf plus c over s squared plus 1. And what ends up happening is a turns out to be 1, b turns out to be minus 1, and c turns out to be 0 from carrying out partial fractions. So we get 1 over s minus s over s squared plus 1, and that's what, and so that, so if we think of this as f hat of s, your f of t, can anyone tell me what the inverse of this would be? Cosine, yeah. Okay. Now, so the last thing you do is you have to take the exponential into account. So, so the inverse transform of e to the minus 3 pi s times the f hat of s that I wrote down over there is going to be, you have a step function, u3 pi of t. And then you go ahead and fill in this f of t, but what is the one thing you have to do to it before putting it down? You have to shift it. So this, so don't forget that. So that'd be, now the 1 doesn't, you don't have to do anything to the 1, but 1 minus cosine t minus 3 pi. So that plus the sine t from the other term ends up being your solution. And as long as actually write it in a shifted form, you don't have to you don't have to do anything further algebraically. You can leave it like that. So questions about any part of what happened here?
Since we don't know what the u, or never mind.
Okay. So when you have an exponential, what you do is first set it aside. Focus on the rest of it. How do you invert that to get your f? What is your f hat of s? To get this needs partial fractions. So invert the rest of it, then multiply by the step function indicated by the exponential, and then shift it. So invert, multiply by step, shift. Those 3 things. Any other? Yeah.
In that shape there,
Oh, sorry, what?
in that circle,
Yeah.
it's like it's the multiple of 1 over s and 1 over s squared plus 1, right?
Correct.
1 over s is the transform form of 1, and 1 over s squared plus 1 is the transform of sine t. So can we just write 1 into sine t?
Oh, the inverse transform of a product is not the product of the inverse transforms. It's actually a convolution, which I didn't cover. Yeah, sums are always easy to handle. Products, no, unfortunately. Any other questions? So what I'm going to do is, so now that I made it to, well, unfortunately I had not started typing the real test, so, because I would have lost it. So on Friday you'll be getting some of these kind of problems that we've talked about here, whether it's higher order equations or Laplace transforms. Then you'll have my feedback on Wednesday when you'll have the whole final in front of you. So result is you'll have in total a little more than 3 hours to do whatever I give you. So no questions about the. Bless you. Oh, whoops. Sorry for anyone who's watching. Pause and read. Okay, so about the lightning round questions, anything? I don't know, 4 or 5, but again, that is not decided. So, you could kind of do 50 minutes.
So we'll get these Friday, and
Right.
then we'll have some like stuff from before on
Wednesday. Well, you won't have any regular problems from older stuff. So these kind of problems are
Okay.
only on newer things.
Okay.
Lightning round covers the entire course. Okay. I'm surprised there were not more questions.
So you're saying Friday is basically like an extension of the final, like we're starting
Yeah.
Friday?
Yeah, so it's the opposite of what happened before. Before you had like the whole 50 minutes to start, and then you had a bunch of the next class period to finish. So now it's kind of like that, where you'll have maybe not the whole 50 minutes, but a good chunk of it, or most of it, to start, and then 2.5 hours on Wednesday to finish. 8. Yeah, where we already slot.
In this question.
In here, yes.
How many questions is it going to be?
It's not going to be to give a firm commitment. What's likely going to happen is I would give like a surplus of lightning round questions. So whatever regular problems you give, you need to do all of them. I've taken into account the time. So what I've done it all depends on whether the lightning round questions are more like just give a short answer, or is there a little something to work out, like a part of a problem or something. What I've done in the past is like when I taught Cal 3, I did this, and I had like 25 lightning round questions in all, but you only have to answer like 15 or something like that. So when this is set in stone, I will let you know. Just so you know, I know what happens in a lot of classes around here. They allocate 2.5 hours for final exam, and everybody's out of there in an hour. I don't do that. Most of you who took 280 from me last semester know that. Not that I aim to make it excessively long either, but I do try to make use of the time, and it is a comprehensive exam.
So on Friday, it's just going to be the last few chapters that we.
Right. Yeah. And actually, these problems, especially the ones from the very last section or variation parameters, they can take a long time. So I'm going to, certainly longer than like the second order equations you had on test 2, and I'll be taking that into account.
So the things that we do on Friday, we cannot do on Wednesday.
Yes, you can.
Yeah.
It's just going to be just like the other test, where I will mark them up. That here's where you messed up.
Okay.
And you get to fix those at least.
Okay. Yeah. Okay. So it's just.
Yeah. So actually, I aim to pick the most difficult problems from those. Okay. Well, since there's still time, I'm going to preemptively, if I can find the right page. Look at number 1 of the Laplace transform problem. Oh. And this one last time. Okay. This is number 6. That's one you asked me about yesterday. Yeah. And I looked at that, and I was like, yep, that is a pain. Okay, so y double prime minus 2y prime plus 2y is cosine t. Y of 0 is 1. Y prime of 0 is 0. So when you transform the second derivative, you get s squared y hat of s. And then from the initial conditions, you get minus y prime, but that's 0. And when you have minus s y of 0, which is 1. And then you have minus 2 transform of the first derivative, which is s hat y, sy hat of s, minus the initial value, which is 1. And then you have plus 2 y hat of s equals the transform of cosine t, so s over s squared plus 1. So now when you gather, and keep in mind, the terms multiplying y hat of s always mirror the differential equation. So it's going to be s squared minus 2s plus 2. So that always works out that way. And then, yeah. Thank you for pointing that out. Imagine someone's yelling at their screen right now. Okay. Alright. S over s squared plus 1. And then the other terms that do not involve y hat of s, let's need to move to the other side. So here we have a minus s, so that becomes a plus s. and here we have a plus 2. So there's going to be a minus 2. And then what ends up happening is, so we have s over s squared plus 1 plus s minus 2 all over s squared minus 2s plus 2. So in this case, when there's no exponential involved, here's where it's a good idea to put everything over a common denominator. So multiply top and bottom by s squared plus 1. Then you get s squared plus 1, s squared minus 2s plus 2 down below. And then up top, there's a bit of distributing to do. Since you're multiplying this by s squared plus 1, which cancels with this one, but then this has to be multiplied by s minus 2. So there's a bit of algebra that ensues, resulting in s cubed minus 2s squared plus 2s minus 2. And now the thing is, the numerator ends up being degree 3. The denominator ends up being degree 4. So there's no need for polynomial. Yes?
Are you multiplying by s squared plus 1 on the numerator?
Yeah, I'm multiplying and dividing by it. Yeah, yeah, that's how I get the common denominator. So this is what has to be decomposed by partial fractions. So you're going to get as plus b over s squared plus 1. And then this right here, you would find, if you're not really sure whether you can factor it or how it should factor, you might want to just try quadratic formula. And what you would find in this case is you get complex roots. But also, one polynomial that's likely familiar to you from many examples is this perfect square, s squared minus 2s plus 1, but then you have an extra 1. So if you can recognize that, that's a good idea. It says something might be a perfect square. So it's kind of like a quick on-the-fly complete the square, because that could be written as s minus 1 quantity squared plus 1. So this is what is known as the irreducible quadratic. Well, these both are. So we have cs plus d over s minus 1 squared plus 1. Now, it's up to you whether you want to leave it in this form or write it in this form for the purpose of doing partial fractions. Doesn't really matter for that. Actually, what I'd probably do, partial fractions, probably leave it like this and write it in this form later. But you definitely want it in this form for a purpose of inverting the transform. So as far as what happens after all of the partial fractions is done, and this is the worst kind of partial fractions, basically, because there are no convenient values of s that will help you pick out A, B, C, or D. All you can do is pick 4 values of s and substitute them to get 4 equations in your unknowns, your constant term, your linear term, your quadratic term, your cubic term. But that's sort of a part that happens after you do partial fractions. Set up the inversion, and you end up with so the main reason I want to look at this problem is the algebraic steps that happen next. Now, here, since you have s minus 1 squared in the denominator, you want to write the numerator as a function of s minus 1 also. Now, the most reliable way to do this and avoid making algebraic mistakes, sometimes when you try to rush through these things, like you miss a sign or something like that. But what I would suggest is if you want to write a function in shifted form, go ahead and force the shift in there and then compensate it. So I'll write this as s minus 1 plus 1, and then put that in parentheses. And over here, There's no shifting to do here, so I'll just break this down into this form. Because then but that's going to be a cosine, and that's going to be a sine. And you want the similar thing going on up here. So now you can write this as 2 times s minus 1 over s minus 1 squared plus 1. And then the rest of this is going to be plus 2 minus 3. So you're going to get, so now you're going to get a minus 1 over s minus 1 squared plus 1. And then so now what you can do is go ahead and invert. This is going to become cosine t. This is going to be 2 sine t because of a 2 up top, and then you multiply 1/5 by all of that. Over here, when it's shifted, what does that do to the inverse transform? Because if you know what this is going to be, this is also going to involve a cosine. This is also going to involve a sine. But because it's s minus 1 instead of s, what is going to be introduced? So a shifted Laplace transform leads to what in your function of t? Yes, an exponential. So because of this shift, that's going to lead to so we have 2/5, and then we still have this factor of 2, and then you have e to the t. So whatever's being subtracted, that's your coefficient in your exponential, cosine t, minus e to the t sine t, plus all this other stuff. So, so remember that. So f hat of s minus a. So if you are writing your transformed function in a shifted form like this, that goes to e to the at times whatever this would transform back to if it had not been shifted. So to be more concrete for this case, I'll just pick out this one right here. So Laplace transform of s minus 1 over s minus 1 squared plus 1, which is f hat of s minus 1. That is the same as e to the 1 times t times inverse transform of the unshifted version. So s minus 1 becomes just s. But then that gives you e to the t cosine t.
Wait, did you say 1 times t or 1 minus t?
Times. Yeah, it's this.
Oh, okay.
Where did you get the exponential?
Wait, this one?
Yes.
That's this rule.
Oh.
Yeah. So in other words, the shift gives me the exponential, and then because it's a shifted form, I know what exponential is going to be there, and then, but exponential times what? So to find out what, I look at what I have here after it's not shifted anymore, and say, oh, I invert this, and that gives me the cosine. So when you have something like this in your denominator, you want to write the numerator also in that shifted form. Make sure that the whole thing, the whole term, is a shifted function of s. So then that's the easiest way to invert it, because then you can say, oh, there's an exponential, and then now you look at the unshifted version and inverse transform that. Well, I think we're almost out of time. Oh, yeah, we're out of time, basically. Okay, so, well, okay, you can try luck on Friday, yes.
You still have to change the 1 over s on the right.
Wait.
After the plus sign.
Oh, that's a 1/5.
Oh.
Sorry. Yeah, if one of the rest, we'd have to do more partial fractions.
Just for saying.
I still have my test two in my notebook.
Oh, good. Okay. Yeah, I'll record it.
Okay.
Thanks. That's one. Right. Oh, for my presentation.
Oh, that okay. Yeah. That was I thought it was a new one.
Oh, no, it's not.
Confused. I didn't
Oh, okay.
Alright, thank you.